I'd like to tell you a little story about myself, just a little bit. I come from a very educated and very smart family. Most of the people in my family are either developers, engineers, or physicists. My grandmother, for example, she is a very specialized mainframe developer, and she's almost 70, but she still gets flown around the world to help people with their mainframe problems. My grandfather is a microprocessor engineer, and both of their sons, so my uncle and my dad, are both brilliant developers. So you can imagine that family gatherings had very interesting conversations. From a very young age, my dad decided that it would be a great idea to teach me how to code. We started when I was about 5. We started off with little calculators, we carried on into little games, and my dad's favorite thing to tell people is the fact that I could count in binary before I could count in real numbers. This is little me with my first computer. As new technologies were emerging, I could see it, especially from my grandfather's side. He was very reluctant to adopt them, especially anything that came from like the Western world. There were new trends that were coming out. For example, Java came around, and it was this new cross-platform wonder that was going to solve everybody's problems. And my grandfather said, well, what do I need to learn this for? I mean, this is probably not going to get adapted by a lot of people. And this got me thinking, in my career right now, I don't want to be one of these people left behind, because this is what happened to my grandfather. I want to learn new things, especially with all of these buzzwords flying around like blockchain and smart contracts and decentralized applications. I literally, when I heard all of these things, I really had no idea what they were all about. And so I really wanted to learn a little bit more about this. I started doing a lot of research. And as you do, you go into Google and you start researching a lot of things. A lot of it was very interesting, a lot of it was very incoherent. And it was just a ton of information in my head, and none of this was really making a nice picture. I started reading, I joined a couple of forums, I started reading some of the other questions that people were asking, because surely I wasn't the only person out there who didn't quite understand all of this. And then you'd laugh, and I should probably pay a little bit more attention to my friends, but it turned out that a few of them started blockchain-based businesses. So that was also a very interesting perspective to chat to these guys, to understand how they implemented this magical blockchain concept in the real world. And so today I'm going to chat to you about some of these new concepts, but before we learn what the future actually holds for us, it's really important to understand where it all started. Now, I hope a lot of you recognize this sound. And if you don't recognize it, that means you're a little bit too young and you probably use words like bay and lit. Now, just like the Middle Ages, Web 1.0 was never given a name until it bit the dust. The World Wide Web, as it was known, was just a bunch of static websites with no interactive contents at all. I don't know if you remember the floating word art type of websites. It was horrific. Connecting to the internet meant dialing up through a modem, and if you wanted to stream a video, well, you could forget about it, and downloading a song would take a whole day. And then came Web 2.0. Faster internet speeds paved the way for more interactive content, and this allowed us to get into the age of the social media. And this is the age that we're currently living in now. Publishing a blog post is going to take you a mere 30 seconds, where in the past it would take a concentrated effort of a whole bunch of website administrators and developers to just make a tiny little change. So if Web 2.0 was so great, what went wrong? With us using services like Facebook and Twitter, there's a ton of information, our personal information, floating around on the web. The UN estimates that the amount of internet users went from about 750 million to 3.6 billion active users. And that is just in 15 years. This is from 2000 to 2015. And as a lot of big corporations realized, all of this data is extremely valuable. And so they began stockpiling all of our personal data on centralized servers. Now I just want to show you a little video on that.
The cloud. You are going to explain this extremely complex piece of technology. Yeah. This is funny already.
Yeah, hey, listen to me. I did some serious research on this, and by that, I mean I looked it up on Wikipedia, and here's Wikipedia's definition of the cloud. Cloud computing is an information technology paradigm that enables ubiquitous access to shared pools of configurable system resources.
Yeah. So what does that mean in layman's terms?
I think it means Wikipedia doesn't know either. Here's what I know. The term cloud is very misleading. It makes you think, oh, my stuff is up there in the atmosphere, floating around, being protected by Jesus. In reality, when you send all your digital files to the cloud, whether it's your photos on your phone, your emails, music, whatever, you're really just sending stuff to someone else's much bigger computer.
Well, whose?
Apple's got one, I think, and Google's got a few.
Very true, right? So we have sacrificed our own security and the privacy of our own information for the services like Facebook and Instagram and Twitter. And as a lot of people started realizing that this is really not the way for the future, and so they started thinking up of new creative ways to get around this. They envisioned that the next web would take a nostalgic turn to Web 1.0, where the internet would be more human and have a lot more privacy. The power would be brought back to the rightful owners, and the web would be more fair and transparent. And unfortunately, until a couple of years ago, about 3 years ago, we had no technology to actually implement this type of web. And then came the blockchain. So the blockchain is basically bringing the means for a more human-centered internet, which we're now calling the new internet. So let's start off with some basics. Unless you've been living under a rock, I'm pretty sure you've heard about the term blockchain. Blockchain is what's going to shape our future. To put it very simply, the blockchain is a ledger of records that is organized in blocks and validated by cryptographic validations. The blockchain is essentially a digital storage, but what's very important to understand here is that the blockchain is not stored in one central location, and it is not managed by one single entity, and hence we call it distributed. Blockchain validations are irreversible, and new transactions, when they get added onto the blockchain, they are there forever, and all transactions are kept there forever too, for everyone to see. And hence we say that the blockchain is transparent and resilient. Now, because I'm sure the majority of us here are analysts, a picture talks a little bit better to us. So let me show you how a transaction actually works on the blockchain. Now, let's assume that someone requests a transaction. Now, for this purpose, don't think of a transaction from a financial perspective. Here, a transaction can involve anything from a cryptocurrency to contracts to records to any type of information. So, a user requests a transaction. That transaction is broadcast to a peer-to-peer network of computers, which we call nodes. This network of nodes then validates the transaction and the user's status using known algorithms. Once this transaction is verified, it is combined with other people's transactions to form a new block of data. This block of data is then gets added onto the existing blockchain in a way that is permanent and unalterable, and at which point the transaction is complete. The most popular blockchain platform that exists at the moment is ETHEREUM. ETHEREUM came about a couple of years ago, and they've built up a huge community that maintains the project on a very regular basis. What ETHEREUM wants to do is they want to replace all internet third parties. So they want to be the world computer that removes the current client-server model. For example, if you think about a service like Evernote or Google Docs, I'm sure most of us have used it at some point in our lives. What ETHEREUM wants to do is to return back the control of the data back to the rightful owners, and that one entity won't be able to control and take down the service. Now imagine if Google decides to take down the server that is storing all of your information. Well, you have no right to that information. It is basically belongs to Google now. You won't be able to get it back. And what Ethereum wants to do is they want to allow the owner to actually control their own information, so only the owner will be able to take down that data. What Ethereum have done is they have developed their own programming language called Solidity. And what Solidity does is it allows us to interact with smart contracts. So the blockchain and smart contracts are two very linked concepts. Smart contracts are basically the programs that we write for the blockchain to interact with it. Smart contracts are the things that hold all of the business logic and the rules for interaction with the blockchain. The most powerful feature of a smart contract is that once it's deployed onto the Ethereum blockchain, you cannot go back and change your program. If you think about a normal contract that usually outlines some sort of relationship between two entities, it's very much up to the interpretation of the person writing and reading the contract. A smart contract enforces this relationship with crypto code. So in other words, a smart contract is a program that executes exactly as it has been set up by the creator. Smart contracts can function as multi-signature accounts. They can manage agreements between two users, so if one buys insurance from the other. They provide a utility to other contracts similar to a software library. And they can store information about an application, such as domain registrations and membership records. Now, I'd just like to show you a bit of an example of how a smart contract can actually be used. Now, I'm sure most of us have heard about or have bought a house. We all know what a tedious process that is. So when buying a house, we've got two main actors, right? We've got the buyer and we've got the seller. And in between the two, we have a whole bunch of different people that who knows what they actually do. We've got lawyers, we've got brokers, we've got insurance, we've got the bank, we've got the deeds office. The whole process takes about 3 months. It costs a lot of money. It takes a lot of your time. Now, if we implement a smart contract in this scenario, this is what we'll have. We'll still have the buyer and the seller because essentially these are the only two parties that should be involved in this process. And then we would have the smart contract that has some logic in it. So basically you can think of a smart contract as a very simplified if statement. So if some conditions are met, something happens. So in this case scenario, to put it very simply, if a buyer pays the money into the seller's account, then the deed gets transferred from one person to the other. So this happens automatically, and so it would really save a lot of time and money for the people involved in this process. Now, smart contracts and the blockchain together, they can't work in isolation. And to bring the two terms together, we associate them as being the building blocks for decentralized applications. The concept of a decentralized application is very new. There is no official definition for it. But to try and explain it in simple terms, a decentralized application is any application that utilizes the blockchain technology using smart contracts. In order for your application to be deemed decentralized, it has to meet 4 criteria. Number 1, it has to be open source. So ideally, your application should be governed by an autonomy, and all of the changes for your application have to be decided by the majority of its users. The code base of this application also has to be available for scrutiny by the community. The second is your application has to be decentralized. So all of the operations and transactions of your application have to be stored on the public blockchain. Your application also has to be incentivized. So all of the nodes that verify the transactions of your application have to receive tokens in return for doing that job. And then lastly, your application has to follow a certain protocol. So the application community must agree on a cryptographic algorithm to show proof of value of your application. And if we adhere to these 4 features, to this definition, the first decentralized application that was ever written was actually Bitcoin. We can also look at decentralized applications from a slightly different perspective, from an architectural perspective. Let's take a look at our normal current existing apps. So your application will have some sort of front end. This front end is usually written with HTML, CSS, JavaScript. That front end then interacts with the back end using JSON or HTTP messaging, and we call this our normal application as we know it right now. Now, what will be different with a decentralized app, well, what's the same, really, is your front end. So your front end is really not changing. Your front ends are still going to be written with HTML, CSS, JavaScript. What's really changing is your back end. Your back end is going to be Ethereum based, and all of the business logic is going to be contained in smart contracts. There are currently about 750 odd decentralized applications that have been deployed onto the Ethereum blockchain. Most of the applications are either decentralized exchanges, games, casino, and other types of games. But unfortunately, nobody has yet written a killer app that really utilizes the blockchain to its fullest. And if we compare these apps to, say, Facebook, these apps really have a very low usage on a daily basis. So even the most popular one has about 3,000 active users a day. Compare this to Facebook that has got like 1.5 billion users. These things are really not getting used very much. The first application that I want to talk about is CryptoKitties, just to give you an example of what people are actually writing for the blockchain. CryptoKitties is a little game where you go and buy a virtual cat. You can take your cat and breed it with other people's cats, and the babies are going to develop cute little features, and the more rare the feature, the more expensive your cat becomes. CryptoKitties became so popular at a stage that it actually clogged the Ethereum blockchain, so the transactions were really, really slow because there were so many people buying little virtual cats. I mean, it sounds ridiculous. There are other companies that are doing a little stuff that's a little bit more serious, so like Golem. So Golem want to become the global market for idle computing power. Through Golem, you should be able to rent computer resources from other users. And then there's another one like Status. Status transforms your mobile device into a node for the Ethereum blockchain. So your phone can become a validator of all blockchain transactions. Now, unfortunately, more than half of the decentralized applications that have been deployed do not actually have, I think almost half don't have any active users whatsoever. And this brings me to the first point of what should an analyst, when dealing with these concepts, think about when looking at decentralized applications. And this is, should you really build this app? So you really need to think about the value that you are bringing to the market when thinking about decentralized applications. And unfortunately, the answer to this question is not very straightforward, so it's not a simple yes or no. Only you and your team can decide whether you should build this decentralized application. It's very similar to a tech stack choice, but developing a DAPP is really going to impact on your business operating model too. You shouldn't be dismayed that the majority of dApps out there at the moment are games. This trend is not going to stick for too long. As people become a lot more comfortable with the blockchain and all of its capabilities, they're going to start thinking about applications that can actually do real things. One of the companies that there is a company in France at the moment that's doing something really, really nice. They are currently selling flight delay insurance. And what they've done is they have linked their smart contract to flight radars all over the world. And what happens is if they basically track all the flights, and if your flight is delayed by more than 2 hours, they trigger an automatic payment into your account. So you no longer need to call someone and try and prove to them that yes, you were delayed. This happens automatically through a smart contract. A lot of people also assume that the blockchain and Ethereum are extremely unregulated and there are absolutely no standards and you can basically do whatever you want. Well, this is not true at all. What Ethereum has are things called ERCs. An ERC is an Ethereum request for comment, and it basically contains technical guidelines for the build-out of the Ethereum platform. Anyone in the community can submit a proposal for the improvement of Ethereum through things called Ethereum improvement proposals. Once your proposal gets approved by the majority of the community, it becomes a standard. This allows the smart contracts to be built with these standards, which is a common interface anyone can access. The most popular standard that's out there at the moment is an ERC20. What ERC20 specifies is the way your application incentivizes the validation nodes. So it's basically how does your app actually produce the tokens and how does it give the tokens to anyone who validates your applications. The key benefit here is that applications and smart contracts can interact with a token in a very standard manner without the need of knowing all of the technical details about this token. So all you're going to need is just the Ethereum token address. The next thing is blockchains are immutable. So if you think about a spreadsheet or a database, you can add rows, you can add columns, you can delete rows, you can delete columns, you can do whatever you want. So this makes spreadsheets and databases mutable, and on the other spectrum, we have blockchain that is immutable. Based on this, the blockchain is extremely trusted, and it is thought that all of the data on the blockchain is true. So because it has been validated by all of the participants on the blockchain. To understand how this works, we need to understand a little bit about cryptographic hashes. A hash is a set of mathematical operations that are designed to output a digital signature on any digital data. A digital signature is called a checksum. So developers have access to different hash functions in most modern programming languages. The implementation of the actual hash is not quite important for our purposes. All we need to really understand is that you put some sort of data into a hash and it returns a digital signature for your data. So the way it works on the blockchain is every single block will have its own digital signature, but what it also has is the signature of the previous block that it's linked to, which means that if someone tries to alter the data in a block, the hash becomes invalid, deeming the whole block invalid too. Now, just like the cloud, the blockchain is vulnerable to attacks. So we need to really take care to build decentralized applications without loopholes. If you go online right now, you're going to find a ton of articles about blockchain and decentralized applications being hacked. One of the biggest hacks that has happened in the recent times is the DAO hack. The DAO was a decentralized autonomous organization, and what they wanted to do was become a venture capital fund for the crypto and decentralized space. They didn't want to have a central authority, which would then reduce the costs and really allow people to have more access to investors. I think it is thought that the DAO had the biggest crowdfund that happened in the recent times. They managed to raise about $150 million. The way it was meant to work was people would come to the DAO with a project or an idea. Anyone with a DAO token would be able to vote for that idea, and in return, if that project turned to profit, they would receive some sort of compensation. Now, unfortunately, a hacker found a loophole in the coding that allowed him to drain the funds out of the DAO. The hacker drained about half, but never returned, and nobody really knows why. But what the loophole entailed was the hacker was able to ask the smart contract for Ether back and forth multiple times before the smart contract would update the actual balance. Now, the problem there was that when the smart contract was coded up, nobody really thought about the possibility of a recursive call. And the way the smart contract was also set up was that it would first transfer the money and then it would update the balance. So this was a real big no-no. The Ethereum community really took this into control quite quickly. So they put all the funds back into a hold account so that the hacker wouldn't return and take the money. But unfortunately, this made the news, and the American Securities and Exchange Commission took note of what was happening in the DAO. They started a big investigation, and what they came out with was to say that any virtual organization that issued virtual tokens would have to fall under the same federal law as any other securities trading company. And this was really against anything what the DAO was really going for. So the DAO has since closed down because people lost faith in their smart contract logic. But what the DAO was able to teach us was a couple of really good lessons. Well, the first is don't leave loopholes in your smart contracts, so really do think about the logic that you're putting into them. And the second is there are other ways to try and avoid central authority. So there have been guys that have been thinking about very creative ways to try and avoid being regulated by the likes of the Securities Exchange Commission. So just to recap on the 4 things that we really need to think about when dealing with decentralized applications, and that is the value of your DAPP, so should you really be building it? The standards, so what standards does your application need to comply with? The immutability, so your smart contract really has to it can't have any loopholes in it, and the security of it as well. So now I've given you a lot of information about blockchain and Ethereum and smart contracts. So what should you really do about it? Well, the first thing I want you to do is to do a lot of research. So with your morning coffee, maybe tomorrow morning, go and just for half an hour, it's really not going to take too much time out of your day, but just for half an hour, start Googling a couple of things. Eventually, just like what had happened with me, things are going to start, a nice picture is going to start coming in your head. You're going to start understanding a couple of things, even if it's at least at a conceptual level. You're going to be able to hold a conversation when somebody asks you about blockchain and smart contracts and decentralized applications. For example, what you can do is tomorrow you can go and read about the difference between a decentralized ledger and the blockchain, which is also very interesting. The next thing I want you to do is to practice all of this new knowledge that you're going to gain. Because after all, practice makes perfect. And there's a really cool application out there called Crypto Zombies. What Crypto Zombies allows you to do is to build your own decentralized app. The decentralized app that you're going to build is very similar to CryptoKitties, so you never know, you might build something great that's going to block the Ethereum network again. And I know what a lot of you kind of think, well, I'm an analyst, I don't code, this is probably not for me. The times are changing, and I believe that all analysts need to learn how to code and need to gain some technical skills. So by using Crypto Zombies, you're going to practice your knowledge and you're going to learn a new skill too. And then lastly, I just really want you to open your mind. So start questioning the way we currently do things at the moment. For example, why do we need banks at all? Why do we do payments in the way we do them right now? If a payment is only supposed to be between me and another person, why do we have to have the bank involved? And I know it will be very scary at first, and you will be that person with an unpopular opinion. I'm always that person with an unpopular opinion. But the future is waiting, and it is very exciting. All right.